We're going to be joined by Ray Heineman from Spectra and Jay Bartlett from SoleraTec, who are going to help me get through a presentation today on digital in-car video systems, an acronym that I first saw LAPD use, DICVS. I don't think there's a polite way to say that acronym, so we'll just call it the digital in-car video system. And basically what we're going to review today is what is a DICVS, what does a comprehensive solution look like, some of the components. We're going to explain how our system works, and we think that this is a pretty good model for how future systems should be architected, whether you're using our system or you're using somebody else's, one of our competitors' systems. The presentation should last about an hour. Hopefully we'll get the presentation material done quickly, and then we'll open up the floor for questions. If you have questions, please use the question box as part of GoToWebinar, and I will respond to the questions at the end of the presentation. I'm going to try not to interrupt the flow of the presentation by taking too many questions, but if it's urgent, I'll be reading them as we go along. So what is a digital in-car video system? And by most definitions, people have been calling it a NVR for a car, network video recorder for a car. And we see that a lot of customers today, particularly police, transit agencies, ambulance, fire, those types of applications, the expectation is that they are delivering a system which is basically just recording. Maybe it's got some GPS data, maybe it's tied to license plate recognition, but that's about the extent of the integration. And we really think that a digital in-car video system needs to be much, much more. And really, we're looking at this as a flight recorder for vehicles. It's a black box, so to speak. And, it's kind of a pun because our micro NVRs are black boxes. We've defined, together with Spectra and SoleraTec, an architecture that we refer to as Mobile Video Vault. And really, what we're trying to do is pull together data from all of the different on-vehicle systems, correlate that data, and put it into a repository where the data becomes useful information. Today we're going to talk primarily around what we'll call a store and forward architecture as opposed to a live view. Live viewing is an addition to the architecture and has its own set of complications and requirements that will be a presentation unto itself. So we'll be offering that a little bit later. But basically, we're going to be talking about how to gather the video, what are the video sources that you need to consider when you're putting together a system like this, why do you want to gather that video, how do you transfer it, how do you store it, how do you archive it, and how do you retain it and make use of it in the future? Because really, this data is really useless if it just goes into a file system. It needs to be used. So if you look at what a black box is going to do, and we put our Mobile Video Vault as the black box in the center, pretty much every vehicle is going to have some information about the electrical system. There's going to be GPS location, so we'll know the speed and the direction and the current location and the elevation of the vehicle from GPS. Every vehicle, most vehicles, motorcycles are a little bit more of a challenge, but most vehicles have a standard interface called an OBD2. the onboard diagnostic port. It's basically a serial port in the vehicle, and it allows you to spew out error codes and information about that vehicle. And then, of course, we have video. And, you know, most systems are kind of limited to those 4 areas. You know, how is the power consumption, how much battery life do I have left, mostly so that I can switch on or off my system as the battery level goes down. Where am I recording the video, and maybe I might get an error code or 2. But each one of these different vehicle types has unique information. If we're looking at, say, a police vehicle, well, it's relevant for me to record, obviously, the audio, and that audio is going to come from inside the vehicle, on the officer, on his land mobile radio. So audio is a critical component. Light bar status, and you know, whether they have their sirens on, whether they have their flashers on, whether they have their siren on. Gun locks, did they remove their shotgun or their rifle from its gun rack? Most of the vehicles have electronic gun racks and gun locks that you can determine whether they've been ejected. You do have the license plate recognition system. The critical element, do not attempt to make your visual video recording system be your license plate recognition system. And there's a lot of reasons for that, but license plate recognition is basically a sensor application. It requires special cameras, special illumination, faster frame rate. It's really just trying to capture that license plate number, the state of the plate, and get it back out to the DMV system, vehicle registration data, ticketing system, and MVV or your black box, because you want to correlate the license plate with the video so that later on I can search. I may also want to track whether the trunk is open. I may want to track, if I'm in a taxi, the fare box status, if they're using the entertainment system. If I'm in a delivery truck, I may want to use RFID, track the delivery of packages. I may want to use it to check the driver in and out. So a driver may have some security codes or things like that. If I'm driving a bus, I may have things like, are the doors open? Were the doors shut? One of the common uses for the video is trip hazard. Did somebody trip getting on or off the bus? I may also want to use my video for parking enforcement. So if I have a forward-facing camera up in the window of the bus, I may be able to get a perimeter shot of a vehicle that's parked in the bus lane. I may have my license plate recognition application grab that video, and then I may want to be able to send that back for ticket processing or dispatch it for live tow and tow services. On a motorcycle, it's a lot of the same types of information. The challenge with motorcycles is limited power consumption, limited space. They have one small electronics trunk, and that trunk is filled with their land mobile radios, their lights and siren drivers, their location systems, their ticketing systems. They may have a mobile data terminal. All of those systems have to fit in a small trunk, and you do not want to drain the battery. When I'm doing light rail or other types of trains in transit, I may want to have a camera on the operator. I may want to have, again, looking at the doors, looking at the hookups. If the train is extensible, I may want to have sensors that are telling me whether the train has been interconnected and how many cars there are, what the camera is looking at. In ambulance, obviously, I can have all the same siren and light systems, as well as information about patient tracking and medical information. And on school buses, which are kind of a unique type of bus, I may also want to look at the stop arms and the blinking lights, because that becomes a revenue opportunity to pay for my system and as well as to create a safer environment for the children. If they've got the stop arm out and the lights are blinking, it's a crime to pass that vehicle. And if you've got a camera, you've got your license plate recognition, you've got some motion detection, and you have a sensor that's told you the arm is open, now I know that any vehicle that moves past the bus while its arm is out is ticketable, and I can go back to that video, show that the person was driving past me, create an evidentiary piece of information, and issue a ticket or a citation. So basically, there's a lot more to data gathering in your vehicle than just your video. And if you're going to be putting this type of a system in, you need to look at the system from a perspective of how can it interoperate with all these other subsystems. Typically, that's using IP or serial, and we'll get a little more into what's in the vehicle. So typically, and this is sort of our comprehensive overview of how the system's going to work, I would have a mobile video vault system, which is attached to all the subsystems in the vehicle. It's gathering that data. It's gathering the video from the cameras. It's storing it while the vehicle's underway. And then at known transfer points, it makes a wireless connection to a LAN-based network, usually using a 802.11 type of technology. Could be a 2.4 gigahertz, 5 gigahertz, 3.65, 4.9 gigahertz. There's lots of different bands, but I'm making the transfer from the vehicle to a base station. In this case, we're assuming that the vehicle is a bus. The bus comes back to the maintenance yard. The transfer is occurring. And there I have at that bus yard a small server for transient storage. So it may be storage for 3 or 4 days of all of the buses that are maintained in that bus yard. If it's a police station, it may be all the police cruisers that are back at that police station. If it's a firehouse, it may be the vehicles associated with the firehouse. An ambulance, it could be at the ambulance office. School buses could be back at the bus yard, trains in the train yard, etc. But generally, most vehicles are coming back to some known position. And that transfer, you got to make some decisions about how much video you're going to transfer. Jay and Ray are going to go into a little bit about the challenges of the size of the video and the amount of time that you have. But basically, I'm recording video at, say 5 megabits per second. If I start recording that for the entire day, I am going to consume gigabytes and maybe terabytes of data on the bus, on the train, on the ambulance or the police vehicle. And I need to be able to transfer it. Probably not going to transfer everything. So I need to be able to look at events that are going to mark the video to give the video priority and make decisions about what gets transferred first, second, third, and what gets done on a best effort basis versus what is critical. Events are driven by all that other information. It could be something as simple as hitting a button and marking and putting a mark place on the video, and that's kind of a typical thing. But generally, when the sirens are on, I want to mark that. When I'm going fast, I want to mark that. When the lights are on, I want to mark that. Maybe if I'm blinking my lights, putting my headlight flasher on, I may want to mark that. If I unlock my weapons, I may want to mark that. If I open a door, I want to mark that. And each one of those becomes an event. And then what I want to do is be able to prioritize those events for transmission. And that's what the MVV system is really about, is identifying the events, storing the events, marking the video with that metadata, and then making that metadata and the video searchable in a distributed way. Typically, I'm going to bring the video back to that small server at that base station. I'm going to store it for a useful period of time. And useful is going to vary by the application. It may be 1 day, it may be 3 days, it may be a month. But eventually, I'm going to want to move that video off to a large repository somewhere, and I'm going to want to store some of it. Not all of it, but some of it, and it's going to be a subset. Again, that migration requires that I look at the metadata, the tags associated with all the different sensors and pieces of information that I gathered initially, and then I can make decisions about what video to keep or what video to erase and keep moving forward with. Metadata is very important. And if you're looking at selecting a system that doesn't have comprehensive metadata or the ability to plug into many different systems, you've got an issue. And then, of course, the migration and also the consolidation, because one of the things that I may want to do is combine my vehicle video with video that I have from my land-based cameras. So maybe I have buildings, maybe I have traffic cameras. I have multiple video sources, and I want to be able to consolidate those all into one repository, which can be searched with a single client. And that's what MVV is also designed to be able to do. Let's see. Okay, I see that Jay has probably joined us. Jay, is that you?
Can you hear me, Bob?
Yeah, I can now hear you. I got you unmuted. Okay.
You may want to mute me until you want me on.
Yeah. Okay. And so this is the comprehensive solution, which is appending sensor data onto the video to make the video more useful. The other thing that this serves is to provide a repository for big data analysis. And one of the things that we're finding more and more police agencies and even hospitals, insurance companies, attorneys, people like that are doing is they're gathering more and more metadata, and you've heard that term used in the context of the NSA, metadata, which is going to allow me to do things like predictive policing. I can start creating forecasting models of what things may happen, where are the more likely events to occur based on things like weather, traffic, tickets, ticket types, speeding violations, traffic flows, number of vehicles on the road, time of day. All those things can be correlated and analyzed if you have them. If you don't have them, you can't do that kind of analysis. So it's really critical to gather as much as you can from the vehicle at the point of consumption rather than trying to recreate the information after the fact. If you want to learn more about some successes in this area of predictive policing, the Los Angeles Police Department has some really good systems that they've put in place in their RACER division for doing this type of analytics. And if you're a public safety organization, you might want to look at that before you write an RFP for a system like this. The in-vehicle components are going to be very scalable. One thing about our system is it's very modular. So we're building around two basic platforms, the MicroNVR 1000, which is a very small, low power consumption, portable system, which is appropriate for maybe 3 cameras. So a forward-facing camera, a rear-facing camera, maybe a camera inside the cab of the vehicle. The advantage of the MicroNVR 1000 is it's very low power consumption. It's very small, so it can fit into tight places. And yet it's full function, and it's got the serial interfaces to be able to connect to things like the onboard diagnostics or get sensor data, dry contact relay data from light bars and things like that. It's got IP, so it can take network devices, and we really advocate putting network into vehicles, and making the vehicle fully IP capable. That gives you the ultimate flexibility as far as what cameras you want to use, what kind of sensors, microphones, amplifiers, etc. The other thing that the MVV system does is, because it's IP and it's all standards-based, you can feed the video back out into things like a wireless tablet, a low-cost tablet like a Microsoft Surface. The Surface Pro is a great little system. You can put a hardened clamshell around it. It's wireless. It's lightweight. It's easy to install. It's removable, so if you have a ticketing system or an incident reporting system or a delivery system, you can pull it out of a dock and take it in. The MVV systems support 802.11, so you can have Wi-Fi coverage around the vehicle and make the vehicle a network again, so that tablet can roam away from the vehicle and still do important things. We can add options for GPS. GPS is put there as an option. You don't have to do it, but obviously for time and for speed and direction and location, we think it's critical. We also have support for live systems like LTE and EVDO. And again, these systems can be tied into the audio systems, microphones inside the cab. They can be plugged into the LMR radio system. Lots of integration capability, but again, we're creating a wide area, a vehicle area network for integration that's gathering video and data from all the subsystems. If you need a little larger system, we have a MicroNVR 2000. It can support up to 32 cameras. It's for buses, trains, or larger applications. It's a larger system, but its function is basically the same, that it's going to be gathering video and data from all of the different subsystems, processing it, storing it in the vehicle, and then transferring it when it gets to a known point. And these are just some images of what the small MicroNVR. That's a 4-inch by 4-inch by 1-inch device. It's got Ethernet, routing, storage, USB, the COM port or RS-232. It's got a wide temperature range, and it runs Linux or Windows, depending on whether you're using our system or somebody else's software. And this has been validated to be used with a lot of different software. And the MicroNVR 2000, as you can see, that's a larger box, but it has RAID storage. It's got integrated PoE, so it's got a 4-port integrated PoE switch. It's got gig Ethernet. It's got storage, external storage. It's full transportation rated, -20 to 70 degrees C, operating temperature, full shock and vibe. So this platform is a much more resilient platform for larger applications. But the MicroNVR 1000 would be the thing that you put in a police car, a motorcycle, the smaller applications where space and power consumption are important. And we've got a table that shows sort of the applications of each. You can even do body wire, body worn. It's not covert per se, but it's a wearable system, and we have people that have actually put batteries with the MicroNVR 1000 and carried it around. So, as we said, event tagging is kind of the key bit of information that you should take away from this presentation. And that tagging can be from your GPS, from your analog encoder option. So if you've got analog cameras or whatever, we can pull that in. From your video, from your audio, from your OBD2. OBD2 can be cross-referenced with GPS, so that if somebody says, well, GPS has plus or minus this degree of error, because GPSs are not pinpoint accurate, but they're fairly accurate. Clockwise, the GPS is absolutely accurate. but I could cross-correlate my GPS location, speed, direction, elevation, angle of travel. I could take all of that information and correlate it with what the engine and the onboard computer in the vehicle are doing. You can avoid voiding your warranty on OBD2 because all we do is we put it into diagnostic mode and stream the data out. So we get all the error codes, we get information about airbag deployments, brake conditions, the RPM of the engine, the speed of the engine, the gear that it's in. Any kind of information out of the engine can actually, in the vehicle systems, can be captured through OBD2. And then we have analog sensors, power flow meters, dry contact relays, things like that for lights, doors, sirens, flashers, the fare box on a transit bus or in a taxi, the stop arms on a school bus, gun locks, doors, whatever happens to be electrically controlled, we can tell you was that device activated or not. We can also tie into the license plate recognition and grab the date and time off of that, and from radar. The one thing that's really interesting is we were just at a major law enforcement agency for his state, and we asked them about integration between all of their systems. And what was the mobile data terminal, which is providing the license and DMV information and all of the wants and warrants and that type of data, is that tied into the vehicle OBD2? Is that tied into the land mobile radio? Is that tied into the license plate recognition? Is it tied into, all the other subsystems? And the answer was no, because the perception was that was hard, and that why would I want that? And I hope that at the end of this presentation I'll convince you that you actually do want that. Because if you let this information go, you're giving up very, very valuable data that can be used for lots of other things, training, predictive policing, liability mitigation, all sorts of different things, traffic flow studies and resource utilization, efficiency. All sorts of data can be derived from metadata. When the vehicles come to their home location, you're going to want to do a wireless transfer. Cellular networks, wide area, in-motion mobile networks are not really good for moving lots of high-quality video. You want video that's evidence-grade, not video that's been transcoded and compressed so that you can get it over a cellular network. You want it to be high-quality video, and you want to do it in a way that doesn't cost you a lot of money. You want to operate your own wireless network, and that wireless network can be in the yard, and it can be at locations that are along a route. So if I'm a police car and I go to the jail and I go to the court and I go to Starbucks, each one of those locations can be transfer points. And your system may want to do incremental transfers. When you get into a yard, doing that transfer is really a function of how much do you want to transfer? Do you want to transfer everything or the events? How many vehicles are going to show up in the yard at one time? How many base stations have I put in? How close are the base stations to the vehicles? How long are the vehicles going to be present in the yard? And kind of RF design constraints. Do I have overlap between the base stations and signal and noise, and how many channels do I have available? And are those RF channels already occupied with other systems? So there's a lot that has to kind of go into designing the wireless transfer, but the most important thing is that you have some kind of control, that the system, when the cars show up or the buses show up in the yard, the system knows to start the transfer. And if that transfer doesn't happen reliably and it has to restart, that the system has the ability to back up and restart, that I don't risk losing any of my data as a result of that transfer, that's another feature of MVV that we think is really important, is that ability to control where the transfer happens, when it happens, what gets transferred at what priority, and knowing with certainty that I've moved the video. So as a design constraint, from HauteSpot's perspective, that's another big challenge, making sure that you have the right kind of network, and that's what we do, is design wireless networks. So building a system that can support that when 50 vehicles all show up in the yard at the same time and they have 20 minutes to make a transfer during a shift change, what am I going to transfer? Are there other locations where those vehicles may go so that I can do incremental transfers and start and stop as they drive around on their route? So just kind of keep that in mind. And with that, I'm going to turn it over to Jay. Jay Bartlett is the sales VP for SoleraTec. SoleraTec makes video resource management solutions. There are partners in building MVV, and Jay's going to talk us through their architecture and the contribution that they make in their software. So Jay, go ahead.
Thanks, Bob. I'm going to go over just a couple things to try to tie it all together and tie the system in a way, as Bob has been talking, in such a way to have an overarching management system. So there's the MVVs themselves, the individual units, but as you deploy those into multiple vehicles or multiple buses, multiple trains, how do you have an infrastructure? How do you build an infrastructure to bring all that video back? How do you want to have an overarching management policy in place? What is the retention policies that you want to have as an organization? And how do you deliver that video back to your customers? So who needs to access that video? So the slide that you're seeing here is kind of walking through the entire infrastructure. So from the initial MVV units being installed in the units themselves, in the vehicles themselves, and then, as Bob was saying, as those vehicles come back to the bus barn or to the precincts, and then we do the wireless transfer, what video do we want to keep? How do we want to get that transfer to take place? Bring that through and bring into the first stage of storage. And then how many vehicles do we have doing that same job, that same policy? So now we can start to get into some heavy video data loads that we'll need to bring into our infrastructure. At some point, people are going to want to review the video, and that metadata, as Bob talked about, is indeed critical. How do we get to associate the different metadata as Bob went through, keep that associated to the video? That's going to be the ability for us to find the needle in the haystack. If we're going to put together this infrastructure of these in-vehicle recording systems, maybe from a city government point of view, we also have city surveillance. Maybe, as Bob indicated, you also have police officers wearing body-worn cameras. So you have all these disparate systems that you'll want to centralize as well. So how do we deliver a system and a solution that can take in multiple video feeds from multiple sources and centralize that management? And in a moment, Ray Heineman from SpectraLogix will be talking about the storage components themselves. So how do we utilize the storage resources in our environment in such a way to build out this infrastructure, build out the ability to keep all the video, as Bob indicated before, to appropriately tag and set the metadata for that video, and then search on it. And really, at the end of the day, it's about finding that needle in the haystack, about being able to search, find, and get back and present the video of interest based on those metadata tags and making sure also that from an evidentiary point of view, as Bob said a moment ago, chain of custody. How do we have, how do we have complete chain of custody? And our system is geared so that we can have this video be produced and delivered to a court of law and stand up as evidentiary court of law evidence through a complete chain of custody system. So as you're seeing from acquisition in the vehicle all the way through to using multiple storage resources, as Ray's going to go over in a minute, how do we have a system that has that management, that has that overarching management? And really, at the end of the day, as Bob has said a couple of times, hope you take away from this presentation that it's the hardware components as well as the software components that make the entire infrastructure that give you the ability to keep as much of the video as you can, as you want, as you need, to find the needle in the haystack, and to do the searching. And I'm not trying to claim that we're Google for video, but I'm just using the analogy of being able to go to a Google-like capability and do a search, find the video that you need, export the video clips out that you need to then go to courts or to the lawyers or to HR or to whoever. And so I'll just kind of end my piece here by saying that the MVV system is all about the complete end-to-end solution that Bob's been talking about, the chain of evidence capabilities, the ability to have the reliability of the video be in there. How do we make sure that there's no guesswork in, did we get the video, that we do have it, we have the original, untouched, unaltered video that is as presentable for a court of law and is capable of doing why you put a video surveillance system in place to begin with. So with that, I hope that part makes sense. The overarching management part makes sense, and I'll turn it back to Bob or for Ray.
Yeah, one thing, Jay. What about support for other systems besides the MVV system? So if I'm a police department and I already have a system from Milestone or somebody like that, I want to consolidate the video. How do you handle that?
That's a great point, and the part about whether it's Milestone or ONSI or Exact or some of these other VMS systems that are already out there that a city may already have for like their city surveillance, and that was kind of what I was alluding to a moment ago about the different systems that are in play, that we can bring those plus the MVV system plus the like a body worn or the city surveillance, and they're already using Milestone and that. We can sit there and provide that overarching management, and Ray's going to talk about all the storage capabilities to keep the storage affordable, and Ray's going to touch on that and talk about that, about as we bring in all this video from all these different systems, being able to put those in such a way that from that search capability, no matter which system I'm really initiated the video, I can get back to it and again find the needle in the haystack. So thanks, Bob, for bringing that up.
Okay, I'm going to bring on Ray Heineman from Spectra Logic, and Ray's going to talk about, okay, I've gathered all this video, I need to store it somewhere, and I don't want to break the bank in doing that. So Ray?
Thank you so much, Bob. Okay, so let's go ahead and advance to this next. Oh, I think we need to move to a different slide. There you go. So just wanted to talk a little bit about Spectra first, so just to get everybody kind of level set as to the type of products that we produce in the marketplace today. We have a disc line of products, which you see on the left side, and then we produce these digital tape libraries. And the digital tape libraries are for usage for very large repositories of digital storage. And we provide these products to many vertical markets. We're very well known in the high-performance computing in federal business and enterprise, also in broadcast, and and now we're focusing on video surveillance to bring these large storage products in play so that all the video that's being generated by the cameras can actually be retained reliably and at a very low cost in the digital tape libraries. So the technology is very well known in these other industries, and now we're bringing it into the video surveillance space. So let's take a look at the solution that we bring. Again, we also team with SoleraTec, and we've integrated the Phoenix RSM system into our solution. And the product that you see called the Spectra NVR3, so that's the network video recorder, and the 3 stands for record, retain, and retrieve. So there's many ways to get video into our system. And as we talked about earlier, you know, we have the mobile application, so any of the video that's collected in the HauteSpot system, the MVV, you know, as it transfers from the client station to the base station, we're able to bring that video in and all of the metadata that's associated. So when we were talking about the tagging of the data, whether it's the vehicle ID, the camera ID, the officer ID, all of that passes through from the HauteSpot system through into our unit. And then once it sits on our unit, then what we'll do is we'll migrate that video over to the digital tape library. Simultaneously with that, we can also have IP cameras that we're directly attached with. So if this system is in a building and there are IP cameras in the building, simultaneously we can record video from those cameras as well. And as we talked about, was mentioned about VMS systems, so whether it's Milestone, ONSSI, or others, we actually can attach to those systems. So there's 3 ways of bringing video into our system, and we can do all that simultaneously. And again, what we'll do is we'll manage moving the video from the NVR3 appliance to the digital tape library. See the next slide. Okay, good. So this basically shows that type of an application again, where we have remote locations like a precinct, and in the precinct the vehicle would show up or the yard, and we'll do the wireless transfer will occur, and then we'll be capturing the video from the MVV system, and it'll go into the slave system. And you'll see we have 2 slaves, and so those are 2 physically different buildings. And then we will transfer, using a wide area network, all that video back to the main camera building. So wherever that building resides, we can actually use that as a central repository for all the video data. And again, as I mentioned before, we can also support that building's camera video as well. So whether it's coming in from direct cameras or it's coming in from a VMS system, we can record that video. So a little bit more about how the solution works. You know, we talk about the original video passing through the system and being written to the digital tape. Also, when that video comes into the NVR3, one of the things that it does is it does a re-encoding of that video to a much smaller format. So it's approximately 10% of the size of the original video. So you'll have 3 pieces of information. You have the original video, you have the lower resolution video, and then you have all the metadata that's associated with that. We'll package all 3 of those pieces up, and that's actually what's written on the digital tape. And so we'll hold it out on the digital tape, and then the lower resolution video is what's continued to be spinning on the NVR3. So when we want to do a search of the video, it's very high performance because we're only searching on the lower resolution video, and then once you find the video of interest, then we'll go into the digital tape library, we'll pull the original video out, and then we can export it to any means that you would like to have that. One of the other benefits is that let's say that there's some evidence lock that happens, and there's some video of very high interest. So what we can do is we can actually write that video to a secondary tape cartridge, and then that tape cartridge can actually be removed out of the library, and it can be taken to a vault somewhere where it's fireproof, it's safe, and you know that that video will will never get erased, correct? And then when you want to, you can take that tape and you can bring it into any NVR system that's in the facility, and you'll be able to read that tape and bring that video back. So we have some abilities to do some things for video of high value and or for evidence lock purposes. So a little bit about the technology that we use in our product. So we're a partner of IBM. We've been partnering with IBM now for almost 15 years, and we take their tape drive technology and then we build it into the robot systems that we make, which is the tape library. So if you were to come to our facility in Boulder, Colorado, you'd see we have some very large facility there, and we purchase the drives from IBM, and then we do all the design to put them into the product that you see on the right-hand side. There's robotics that are built into that, which moves the tapes around as the system needs that. So we incorporate two different types of IBM technology in the product. One's called linear tape open, or LTO, and that particular cartridge that you see in the middle of the screen holds 2.5 terabytes of capacity. And the one on the left-hand side is their version they call the TS1140, and that tape holds 4 terabytes. And again, these are the technologies that we use in the other vertical markets, whether it's high-performance computing, enterprise accounts, and or broadcast market. So we're pretty proud that we're the only company outside of IBM that actually offers the TS1140 drive. So it really talks to our relationship with IBM and the experience that we have in this marketplace with digital tape drive technology. So what I really like about the system, and I think we've hit on it a few times, is that this is a very scalable system. So as the camera quantities increase and the bandwidth increases, you know, whether it's from direct attached to cameras behind the video management system or from the mobile applications, as that bandwidth goes up, it's very easy for us to expand the system. So we would just add additional appliances as required. And then, of course, we have our full line of digital tape libraries, and we have no problem storing all of the video data that's needed in our systems. Okay.
I think we're at the end. Thank you, Ray.
You're welcome.
Again, the point of this is that what you're really doing with the digital in-car video system is creating a repository of data for lots and lots of different uses. And we're going to have another presentation where we talk about live video, which would be video that gets routed to, say, your dispatchers, or may get routed into a video conference bridge or a distribution system for distribution to a broad audience. And that could be an incident that's of interest that you want to get back out to all the responding people. But when we talk about storage of data, we really start talking about things like, you know, how do I do big data analytics? You know, what can I do with this data besides just create an evidence record, which is a critical function, and you definitely want to make sure that whatever you do, you know, the chain of custody is maintained, that the integrity of the files is maintained, that whatever you do to move the video doesn't leave an opening for somebody to be able to get out of that video evidence. That video evidence remains sacrosanct to the process. But you also want to be able to make people more efficient. When I come back and I want to pull incident records about driver history, or I want to pull my citation record because somebody's contesting a citation in court, I want to be able to quickly and easily obtain that record. And we're really talking about creating digital case files to a large degree based on all the available information in that vehicle. And that's what digital video surveillance is about. If you aren't doing that, you're really not recognizing the full potential and the value of doing a system like this. You know, again, we were at a state agency that had lots and lots of vehicles. It was all a DVD-based system. And what were they doing with that data? They'd pull the DVDs out at the end of the day. They stick them in a file room. And hopefully they don't have to ever go and retrieve them from evidence. But if somebody contests a ticket or something, they can go in and grab it. But all the usefulness and the value of that data is locked in that closet and inaccessible. And we're trying to make this data information that can be used for other things. I'd really encourage people to read up on what companies like Palantir and companies like that are doing as far as big data analytics and some of the very impressive implementations that they've done, like the LAPD racer implementation. They're turning that data into useful information, and they're actually creating better ways to drive resource allocation because they have that data, that the data starts paying for itself because it's there. If you don't have the data, then you just have overhead. And all you've done is created a system for more overhead, and you're really not going to leverage your resources. With that, I think we're done. I'd like to open it up for any questions that people may have. If you have any questions, feel free to type them into the window. We will be doing a poll after we're through the questions, and we'll put those out. In fact, I guess there's already a poll out there that Charlotte pushed out to you. Nobody has any questions? Let's see in the chat window. Nice work, Bob. A lot of info, clearly communicated. Thank you very much. I appreciate the feedback. If you have any other questions or anything, please either chat them to me or ask the questions. We'll go for another minute or so, and if there are no questions, then we'll just wrap it up. Okay then, well, I'm not seeing anybody ask anything. If you can please respond to the poll question. Polls in progress. You know, why were you attending this this seminar? Charlotte, you want to go to the next poll question? I think our next poll is, was this presentation useful to you? And go ahead and just tell us that, and then we'll have one last question. Is anybody seeing that? I'm not seeing anybody vote on that. Can I elaborate on chain of evidence? Sure. So there's a question about chain of evidence. Chain of custody. Basically, when I record video, I need to be able to maintain tamper evidence and to make sure that that video has a known path, a deterministic path, to get from the recorder, the vehicle recorder, into a data repository and ultimately into a courtroom. And there's a couple of criteria for that. One is tamper evidence. And the way that you do tamper evidence is what you'd call a fragile watermark or a CRC check on a particular frame of video, and it's usually done frame by frame so that you can determine if it's been altered from the original. Now, one of the challenges with anything that's an IP camera is what is the original? Is it if the camera has the ability to record on an SD card or something, is that the original? If I'm split streaming it and I'm writing to another destination, is that the original? If I copy that file and I maintain that CRC or digital watermark across the copy, is that still the original? Even though I copied it, if I can prove that the integrity of the file exists, by and large, that's been sufficient. Now, there are jurisdictions where the district attorney has kind of said that you can only make one copy of any video, and that's why we have things like in the micro NVR, you can actually remove the disk. You can remove the micro NVR. We have a mounting bracket that allows the micro NVR 1000 to be easily removed. And we have lockable, removable disk drives on the micro NVR 2000. So that if I actually had a case that I was concerned about making copies of the evidence, I could actually take the physical media out of the device and enter that disk drive into evidence. More and more, we're finding that as long as you've got the ability to prove that the data has not been tampered with, then the system is going to be proven reliable in court. Transmission, again, one of the things that the SoleraTec system does that's part of MVV is that it does a reliable transfer, and it will not close out a file until it knows that it hit its target reliably. And then once we move everything, there are log files that show in the system what got moved, when, and where. If you are downsampling or transcoding the video, which is touching the video at that point for archive purposes, will show what the original file was, what the target file was, and how it was transformed. And that's a mechanical process that would happen in a system that doesn't allow for, can be constrained to prohibit user intervention. So, chain of custody is a very telling thing, very important part of this whole system. And you need to make sure that if you're doing network file transfers, that the system has been vetted and people know where it's going. So that was a good question. Any other questions? Okay, and our poll, I don't know what happened here with our poll.
The LTO cartridge?
Was there a question about the LTO cartridge? I didn't see one there.
Maybe.
Oh no. Let's see. No, I didn't see that. So it must have come directly to you.
Okay. So there was a question about what's inside the storage cartridge, and somebody provided an answer. Not sure who it was. It wasn't me, but the linear tape open, it is a magnetic tape that's inside the cartridge. The cartridge physically is 4 inches square and about 3/4 of an inch tall, and then the tape is where all of the digital information is recorded to.
And those tapes, the life cycle of those, what's the expected lifetime for one of those tapes?
Well, there's a number of ways to express that. The durability of the tape, once it's been written and we actually take it out of the tape drive and we store it in the library, the shelf life is 30 years for that tape. So it has a very long shelf life for the tape. The number of times that you can actually put the tape in the drive and read and write it and use it is tens of thousands of times that you can do that with. The technology is very similar to what's used on other magnetic recording, where we have we have many heads that we use to write the information with. We have the ability to position the read-write heads on the media itself. So there's a lot of high-end technology that's built into these products in order to obtain the capacity and the reliability of them.
Great answer, Ray. Thank you. Well, I'd like to thank both Ray and Jay for joining us today, and of course all of you. Thank you very much for participating, and watch for the next seminar that we're going to be doing. Of course, we're going to be at ISC West, and if you'd like to come and visit us at ISC West, Charlotte, what is our booth number at ISC West? What's our booth number? Oh, it's posted on our website, 11131. So 11131 will be our booth. We'll have all of our products there, and we'd be happy to answer any questions or help you with design projects that you have for mobile video vault and digital in-car video systems. Again, if you have any questions, give us a call or send us an email. We'd be happy to help you out. Thank you very much, and have a good rest of the day.